Hello everybody and welcome back. Today we're going to talk about the squeeze theorem and how this is applied. So for our first example today, we're going to say ace of n equals cosine squared n all over 3n. Okay, so when doing the squeeze theorem, the first step is to always pick a portion of your problem that you know. So, known. We know cosine of n is always bounded between 1 and -1 due to the unit circle. So from this point, we can just keep moving on and adding on different portions of this problem, such as the squared and the 3 to the nth power. So for the second portion, we're going to drop right down. We have cosine, and we're going to plug in our squared n. Now I know anything that's squared here has to be positive, so now we're in the first quadrant, which is between 1 and 0. Knowing your unit circle will help tremendously in this section. Alright, last step is adding on our divisor. So now we have cosine squared n. This was still between 0 and 1. Now we're going to divide it off by 3 to the nth power. What you do to one portion, you have to do to the others. Okay, now that we have that, now essentially what we do in this point is we are looking at the ends. So the 1 divided by 3 to the nth and 0 divided by 3 to the nth. We are taking the limit of these. So I know that this will go to 0 and this will go to 0. So we're plugging in the limit as n goes to infinity, and then what am I given? So plugging those in, we get 0. So by this, we know that it equals 0 by the squeeze theorem. All right, let's go ahead and look at another example. So for this next example, we're going to do a tangent inverse. So if we're given ace of n equals tangent inverse of n all divided by n. So what do we know? Known. So tangent is, for me personally, the hardest one to memorize. But I know tangent inverse is bounded between pi over 2 and pi over 2. So pi over 2 and a negative pi over 2. This one helps just to memorize. So we have the main portion of this problem down. We just have to do our divisor. So going one step back, we have our tangent inverse of n, which we knew was between pi over 2 and negative pi over 2. So let's just go ahead and write those out. Over 2, negative pi over 2. But here we need to also divide by n. So we have one last step, divide that by our n. And here, because it's on the denominator, we're just going to multiply the 2 by that n. All right, same thing. We're going to take that limit of the n portions, so this portion and this portion. So as my limit goes to infinity, so the limit as n approaches infinity, this will go to 0 as well as this. So this equals 0 by the squeeze theorem as well. Perfect. All right, for a final example, we're going to go ahead and do an easier one. So it wants to compute the limit as n goes to infinity. And the problem is sine n over n. Sine of n over n. Okay, this is the exact same problem. It's just written a little differently. They're giving you the limit. So what we're going to do is we're going to test the squeeze theorem with our sine. So first step, known. What is known about this problem? We know that sine of n is bounded between 1 and -1 as well, due to the unit circle. Step 2, let's go ahead and keep adding what we know. So I'm now going to add my divisor, which was n. So this was 1 and -1. we're going to go ahead and divide by that final n, divide by n, and divide by n. Now what we're going to be doing is taking the limit. So once we take this limit, it should be fairly easy to understand where this is going. All right, switch here. So what is happening right here and right here? As I take the limit, with n approaching infinity, we're going to essentially plug in infinity everywhere you see n. So plugging it in here, I'm going to get 0 again, and plugging in here as well, I'm going to get 0. So for the third time, this equals 0 by the squeeze theorem. I hope this helps visualize how to do the squeeze theorem on cosine, tangent, and sine. If you have any questions, please leave a comment and I'll do my best to answer them. Until next time.